Hello students, welcome to your channel Sukh EduWorld. So in this video I am going to solve 15 questions, and remaining 15 questions of this question paper I'll solve in the next video, and that video will be uploaded this evening, and then you can practice, and all the best for your exam. Let's start. In beta emission, the transformation of a neutron to proton within the nucleus take place according to. So four options are giving, and this is beta negative emission, and emission is beta negative only in A case. Okay, A option. So A option is your correct answer. So in beta emission, actually a neutron is transformed into proton. Okay, and this process can be represented in this way. Okay, so you know this is neutron, and this is proton, and these are the antineutrino particles. Okay, so A option is your correct answer, and this process helps increasing the atomic number by 1, atomic number by 1. Okay, while keeping the mass number unchanged. So atomic number increases by 1 and mass number remain unchanged in this process. Clear? A option is your correct answer. In the next question, PCl5 undergoes sp3 dehybridization to form 5 equivalent hybrid orbitals which are directed towards the corner of. So PCl5. Okay, so its hybridization is sp3d, and corresponding to this hybridization, its structure will be trigonal bipyramidal. Okay, so A option is your correct answer, and its structure is in which 3 bonds are equatorial position and 2 bonds are at axial. Okay, so A option is your correct answer. In the next question, for a given value of principal quantum number n, okay, degree of penetration of electrons will decrease in the order. So 4 orders they are providing you, and out of 4 options, A option is your correct answer. Okay, so actually for a given principal quantum number, the penetration of electrons decreases in the order A, as given in the A option. So because s orbitals are spherical and have highest probability density near the nucleus. Okay, so if we consider p, d and f orbitals, which are progressively more complex and have nodes that reduces their electron density near the nucleus, so that's why penetration power, a degree of penetration of electrons in the case of s orbitals are maximum, and in the case of f orbitals are minimum. So A option is your correct answer in this question. In the next question, the dissolution of an ionic compound in a solvent involving electrostatic force of attraction between oppositely charged ions must be. So in this case, electrostatic force of attractions between oppositely charged ions must be reduced. Okay, A option is your correct answer. Okay, because a solvent with the high dielectric constant, okay, so which weakens the electrostatic force between the ions and allowing them to separate and dissolve. So in this case, the dissolution of ionic compound in a solvent involving electrostatic force of attraction between oppositely charged ions must be decreased. Clear? So A option is your correct answer. In the next question, it is seen that alcohol exhibit a higher boiling point than hydrocarbons of comparable molar masses due to. So its correct answer is hydrogen bonding. Okay, so alcohols involve intermolecular hydrogen bonding. Okay, so alcohols involve this hydrogen bonding, so that is absent in hydrocarbons. So obviously due to this hydrogen bonding, alcohols exhibit high boiling point as compared to hydrocarbons. So B option is your correct answer. In the next question, they are saying a graduate student prepared a buffer solution by mixing equal concentration of acetic acid and sodium acetate. What will be pH of the buffer solution? So you know that Henderson-Hasselbalch equation, which is according to that pH equal to, because they are mixing acetic acid plus sodium acetate. Acetic acid, which is weak acid, and just salt, sodium acetate. Okay, so its equation is this. Okay, so this is concentration of anion and this is concentration of acid. Clear? So they are saying, as in this case, Ha is your acid, right, which is acetic acid. Okay, so A negative is conjugated base. Clear? And according to them, they are saying a graduate student prepared a buffer solution by mixing equal concentration. So equal concentration of acetic acid and sodium acetate. They are saying concentration of conjugated base, which is sodium acetate, you can say, and acetic acid is equal. So you can take its concentration, suppose 1. Okay, or if any concentration which is equal, in that case you can cancel out this number because concentration are same, so you will get here log 1, right, and its value is 0, so you will get only pH equal to pKa, and this is in your C option. So C option is your correct answer. Clear? In the next question, total valence electrons in two atoms of aluminium are Z. Total valence electron. What is the value of Z? So you know that total atoms of aluminium. Okay, so aluminium has atomic number 13, right? Okay, and belongs to group 13. So it means one aluminium has 3 valence electrons, and they are saying there are 2 atoms of aluminium. It means one has 3 valence electrons, so 2 has 3 into 2, 6 valence electrons. Clear? So C option is your correct answer. In the next question, which of the following products is formed when acetylene reacts with dilute sulfuric acid in the presence of mercuric sulfate? Okay, which of the final product will be formed? Okay, so in this case your correct answer is ketones. So actually this reaction is known as Kucherov's reaction. Okay, Kucherov reaction. So in this case, acetylene reacts with the sulfuric acid in the presence of mercuric sulfate to synthesize ketones as your final product. Okay, so B option is your correct answer. In the next question, transition elements have high melting and boiling points due to their ability to use both n-1 d and ns electrons for metallic bonding, only n-1 d, only ns, and F and P. So you know that they are talking about transition elements, so D option is incorrect. Okay, so in this case B and C options are also incorrect. So correct option is A. So a transition elements involves both D and S electrons for metallic bonding. Clear? So this extensive delocalization of electrons strengthens the metallic bond and contributing to their higher melting and boiling points. So A option is your correct answer. In the next question, which among the following mixtures is used in the welding process? So in this case they are providing you four options. First is oxygen and nitrogen. So this is incorrect. Second is oxygen and acetylene. Yes, this is correct option, and other two options are also incorrect. So oxygen and acetylene. Okay, which among the following mixture is used in the welding process? That mixture is oxygen and acetylene. Okay, so this mixture is commonly used in the welding process, especially in oxyacetylene welding, which is also known as gas welding. Okay, so combination of oxygen and acetylene produces a very hot flame, okay, reaching a temperature of 3500 degrees Celsius. So this temperature, which is ideal for melting metals and welding them together. So correct option is B, which is oxygen and acetylene. So I'm leaving this question 31st because there is an issue in the options. Okay, so options are incorrect. Still I'm trying to solve it, and I will check it again and will try to solve it in the next video. So I'm leaving this question in this video. In the next question, which of the following is not a deformation process? Okay, so in this case they are providing you four options. One is forging, second is extrusion, third is rolling, and fourth is coking. So in this case your correct answer is D, which is coking. So coking is a process in which coal is heated. Okay, coal is heated in the absence of air, okay, to produce coke. Okay, so a porous solid used in a metallurgical process. So it is not related to deformation process, but if we are talking about other three options, that are examples of deformation processes. So D option is your correct answer. Okay, which is example of metallurgical process. So this is metallurgical process, which is cooking. Clear? So D option is your correct answer. In the next question, which among the following carbohydrate is an example of ketohexose? So out of four options, D option, which is fructose, is your correct answer. Okay, because involve keto group, which is ketone group in its structure. So if you look at the picture or structure of ketone fructose, it has, okay, so similarly in this side, so this there is a presence of ketone group in this structure of fructose. Okay, so they are talking about carbohydrate, which is ketohexose. So it has 6 carbons. Okay, so D option is your correct answer. Next, I'm also leaving 134th question in this video. Still I'm trying to solve it. Similar issue is in this question. Okay, so maybe options are incorrect. Okay, I will check it again. So I'm leaving this question also and will solve it in the next video. In next question, many transition elements form non-stoichiometric compounds due to. Okay, so there are four options they are providing you, and its correct answer is variable valency and defects in solid structures. A option is your correct answer in this case, in this question, because many transition elements form non-stoichiometric compounds because they can exhibit variable valencies. Okay, it means they can exist in multiple oxidation states. So this coupled with defects in their solid structure such as valencies, or you can say interstitial atoms, so that lead to deviations from the ideal stoichiometric ratios. So variable valency and defects in solid structure, that is A option is the correct answer in this question. Okay, so remaining questions I will cover in next video. Okay, I will finish this question paper in the next video. And if you like the video, okay, share it with your friends, subscribe the channel. Thank you very much.